In this lesson, I am going to teach you what is an area vector. Now, if there is a surface, that surface will have an area. This you have already learned in your school maths, right? Now, area is a scalar quantity because area has only a magnitude. This much square meter or this much square centimeter, right? Now, how can it be a vector? Now, what happened is that scientists realized at a certain time that they needed the area to be treated as a vector so that they can use it in some calculations. Now, area is a scalar, it has only a magnitude. So they found out a way to make it a vector. So they named it area vector. Okay, now as you know, for a vector there has to be two things. There has to be a magnitude and there has to be a direction. Now the magnitude of the area vector is the normal magnitude of the area. Say if we have this surface will have an area, so this much square meters. So if we call this an area vector, the magnitude of the area vector will be that many square meters. Okay, there is no problem with this. Assigning a magnitude to the area vector was not a problem. It is the same quantity as the area of this surface. Okay, now what they needed a direction. A direction had to be assigned to this area vector. So what they decided is that a normal to this area, that is perpendicular to this area, will give the direction of this area vector. Okay, so for example, if the area is this, area is facing me, then the perpendicular on this, that is this direction towards me, that will be the direction of this area vector. Clear? If this area is like this, then the direction of this area vector will be towards you, normal to this, towards you. Okay, if the area is horizontal, this surface, then the direction of the area vector will be vertically upward. Clear? If I say it mathematically, if the area is in the YZ plane, then the direction of the area vector will be along x-axis, right? If this is x-axis, this is y-axis, this is z-axis. So this surface, I am holding it in YZ plane. So direction of the area vector will be along x-axis. Clear? So this is the way they converted a scalar quantity area into a vector quantity called area vector by assigning a direction to this surface. I repeat, what is the direction of the surface? It is along the normal to this surface, and there is a small word there, it is along the outward normal to this surface. Now what is the meaning of the outward normal? Let me explain that. So let's consider this book. This is a three-dimensional object because there's a measurement here, and there's a thickness here. Okay, now say I consider this surface. So if I consider this surface and I want to make it an area vector, then the magnitude of the area vector will be this multiplied by this, that is the area of this surface, and its direction will be along this direction, normal to this surface. It is coming out of the object, so outward normal. Okay, if I consider the other surface, in this surface which is facing me, okay, so its direction will be towards me. Clear? Now if we consider this surface, then its magnitude will be the area of this surface, its direction will be normal to this, along this direction. Clear? If we consider the top surface, the direction of the area vector will be vertically upward. So the direction of the area vector is defined as the outward normal to the surface. Clear? Cool.